Our project's primary focus was on the tubs portion of their product, which hauls and dumps the loads. We wanted to focus on the welding processes to manufacture this product. Currently, SmithCo's capacity cannot keep up with the demand. So their goal was to increase their annual production of tubs. Given their workforce and production limitations, they really thought that welding automation would be a great solution to implement to increase their capacity. So for this project, our primary question was how would we know if an automation design would perform better than their current state? These discussions led to formulation of our objectives. We wanted to first analyze the value-added and non-value-added time spent during the current processes, as well as to establish the standard time per task for both the SX tubs and the frames manufacturing process, and finally use all of this data collection to evaluate an automation vendor's design for technical ability, capacity ability, as well as ease of implementation. So these objectives guided us through our data collection to understand their current state.
One of the ways that we collected data for this project was through work sampling studies on the frames and tubs areas. Because the facility was so far away, we used recorded video, like what's on screen right now, to do the studies. We watched a few seconds of video every 5 minutes and marked down what the welders were doing. The results from our work sampling studies showed that welders in the tubs area spent about a quarter of their day on value-added work, about 6% of their day on non-value-added but necessary tasks, and about 70% of their day on non-value-added tasks. However, in the frames area, welders spent closer to 42% of their day on value-added work and only about 51% of their day on non-value-added work, with about 7% as non-value-added but necessary tasks.
We also did time studies for this project to compare the manual welding times to the automatic robots. So to do this, we'd watch to see when we'd see a weld spark, record the start time, and continue watching until we saw the spark go away and then record the end times. We did this for every single task in the tubs process and the frames process.
Results of the time studies were very telling for the production cycle times for both tubs and frames. For tubs, the average value-added time spent manufacturing the tub was only 4 hours and 22 minutes. However, the average labor hours spent on the tub was 10 hours and 23 minutes. Therefore, only 42% of the time was spent on value-added tasks. Similarly, for frames, the average time adding value to the product was 8 hours and 8 minutes, while an average time of labor hours put into the frame was 10 hours and 57 minutes. This is a better percent of value-added time at 74%. However, there is still room for improvement for both. Alongside understanding the overall time to complete the tubs, we also got a deeper understanding of individual task cycle times. This gave us great information to take and apply to automation vendors to see how much would be reduced given robotic welding.
Based on the results of our work sampling studies and our time studies, as well as our investigations into automation vendors and their capabilities, we recommended that SmithCo pursue automation as a way to help increase their throughput. More specifically, we recommended to SmithCo an automation design that should increase their throughput in the tubs area by about 93%.
By adding automation to this process, we're going to be changing the work that these welders are doing. Hopefully, we'll be making their jobs easier because we're taking some of their hardest tasks and giving them to the robots. This will be changing their manufacturing process as well because they'll be able to output tubs faster, but don't worry, the welders that aren't working the robots will be helping in other areas of this process to make sure this is still line balanced. This was a really fun project to work on this semester, so we just want to thank SmithCo for their patience and for trusting us with this project, specifically Dan, Ryan, Matt, and Scott, and we also want to thank Dr. Sly for his mentorship through this project.